Great. Good evening, everybody. Really pleased to be given the opportunity to speak with you this evening about electric vehicle charging infrastructure, which has been my life for the last 6 years, or it feels like a lot longer than that. But the industry's moved on so long in such a short space of time that, yeah, it can feel like a lifetime in the industry. Today, I'm going to be aiming to provide you with a bit of an overview of electric vehicle charging infrastructure. I'm going to try and make this as relevant to energy systems and the energy networks as I possibly can. But there's an awful lot of, I suppose, background information that I'll be providing alongside this, which means this talk, it will go on for quite a while and there'll be a lot of ground to cover. I'm hoping to talk for about roughly half an hour, maybe a little bit longer, and then leave as much time as possible for questions. And on that topic, you can submit questions as we go along. And once the presentation is over, we'll then go through the questions and I'll do my best to answer them. So firstly, to introduce myself, my name is Jacob Roberts. I'm an infrastructure strategy specialist at CENEX, which is a not-for-profit research and technology institute based in Loughborough that specialises in low-carbon transportation. We go on to the next slide. This is just a bit of an overview as to the sort of work that we do. We work with public and private sector organisations to help promote, encourage and support the uptake of low emission and zero emission transport solutions. Our company broadly is split into two main themes. On one side, we have transport, where we work with fleets and with vehicle operators, but also automotive industry to help decarbonize vehicles and the way that we use vehicles. So using electric vehicles, hydrogen vehicles, but also using conventional vehicles more efficiently. And then on the other side, we look at energy infrastructure, which is the side of the organization that I sit in. In the energy systems and infrastructure team, we look more at how we prepare infrastructure systems to support the uptake of low and zero emission vehicles. So as you can imagine, a lot of this is focused on electric vehicles over the past few years, but we also look at hydrogen in some detail, and increasingly we're looking at things such as mobility hubs that bring together different forms of transport, public transport, active transport, and electric vehicle charging infrastructure into single locations. But the topic of today's presentation is very much focused on electric vehicles, and hopefully I'll be able to give you a crash course in all things EV and at least leave you in a position where you have a good idea of what sort of questions to ask at the end. My career, just to introduce myself in a bit more detail, I began my career in local government. I started at Coventry City Council and managed some of the initial low emission transport development projects there. After a few years at Coventry City Council, I moved to Energy Saving Trust, where I worked between the Department for Transport, the Office for Low Emission Vehicles, in administering some of the government funded grant schemes, looking at electric vehicle charging infrastructure. And then just under 2 years ago now, I moved to CENEX to focus more on consulting with local authorities and with private businesses to help support them to bring across a sort of a transition to electric vehicles and zero emission mobility. Now onto the presentation, the contents. Firstly, I'm going to provide you with a little bit of a national overview of electric vehicle charging infrastructure. So we're going to look at what the state of the industry is, how many charge points there are installed already, how many do we need to install, and what's the real context behind this, what are the policy drivers behind why we're looking to install EV charging infrastructure. That's a good place to start, and then from there I'll be introducing some of the basics around electric vehicle charging equipment in general. So what different types of equipment there are, what are the specific use cases that each type of equipment is most applicable. I have a few slides looking at more innovative charging technologies. So these technologies, some of which are at market, but in quite an early stage of development. Others are very much at a feasibility stage, if not demonstrator stage. But there's some quite exciting technological developments coming up, and I'll be talking about some of those and where they fit into the wider ecosystem. A topic that I'm quite passionate about and looking forward to talking with you about is the societal challenges of electric vehicle charging. So what kind of challenges are we likely to encounter as we install more EV charging infrastructure and as more people adopt electric vehicles. Some of this is well known. The challenges are well known, and we're already taking actions to mitigate them and overcome them. Other challenges are considerably less spoken of, but arguably more significant, and I'm quite looking forward to the opportunity to speak with you about that. And then finally, to bring it back to the topic of the energy networks and energy systems in the UK, I've got a few slides prepared for you that look at how electric vehicle charging and the electricity grid, electricity networks interact, where the challenges are, and potentially where the solutions are as well, because EVs present both a challenge and a solution in a lot of energy network related topics. So the first part of the presentation, looking at the national overview, looking at vehicle uptake, the extent of the UK electric vehicle charging infrastructure network, and also where we're heading in the future. I've got a few snippets on the screen there that summarise sort of the policy background to why EVs are such a big thing. Towards the end of Theresa May's tenure as Prime Minister, she committed the UK to become net zero carbon by 2050, which is something I'm sure many people are aware of on this group. Shortly after that, the UK Parliament declared a climate emergency, and even before that happened, local authorities and organisations from across the UK and indeed across the world had already started declaring climate emergencies. As it stands now, just over 300 UK local authorities have declared a climate emergency. So there's a clear call to action at a political level for us to reduce our carbon emissions, which again is something I'm sure attendees of this group are very familiar with. Now, in response to that, with transport being a significant and I believe the largest contributor to UK greenhouse gas emissions now, the UK government has periodically moved the goalposts on ending the sale of petrol and diesel vehicles. Back in 2017, I believe, they published their Road to Zero strategy, in which they outlined how they were going to end the new sale of petrol and diesel vehicles by 2040. Early in 2020, the government started a consultation on bringing that date forwards, and it was widely believed that that ban was going to be brought forward to 2035, and in the end, it's been brought forward to 2030, which is ambitious without a shadow of a doubt. And there's the implications of that are that we now need to think about the infrastructure requirements and move as quickly as possible to make sure that the infrastructure is ready to support that transition. And what that transition looks like is this. So on that graph, we've basically got an even distribution of EV uptake plotted out to 2040. The different lines show you different rates of uptake. So the solid line is ultimately the rate of uptake that would be projected if we were going to end the sale of new petrol and diesel vehicles by 2030. The hashed blue lines after that look at 2035, 2032, and 2040, showing how that policy impacts the rate of uptake. And then the green lines basically translate those sales into how many vehicles are on the road. So you can see in the dark blue line, we're talking about almost 90% of all vehicles on the road becoming electric vehicles by 2040. How has this been developed? It's not particularly any crystal ball gazing magic or anything like that. It's simply an application of a simple distribution and that forming an S-curve. So at the moment, we're very much in the early adopters stage, possibly even still the innovators stage of EV adoption. But as vehicle technology develops, and particularly as vehicles become cheaper and cost parity between electric vehicles and petrol and diesel vehicles is achieved, that's when we're going to get to the crest of that distribution. And that's when we'll see the sales really ramping up and moving along at quite a pace. And that's going to happen in the next few years, almost without a doubt. There's not many people in the industry that don't believe EVs are likely to be a mainstay of the transport system in the UK in the future. So what does that mean for infrastructure? Well, I'll start with where we are now. Stats that I drew towards the end of last year showed that we just installed the 20,000th public charge point in the UK. Now that diagram from ZapMap on the left is, I think, if you're ever confronted by somebody that says there's not enough charging infrastructure in the UK, I struggle to find a better image than that map of the UK buried under the charge points included on the ZapMap website. And for those of you that aren't aware, ZapMap is probably the foremost source of electric vehicle charge point mapping that's open to the public and helps electric vehicle owners to find the nearest charge point and plot their journeys, especially over longer distances when they need to stop to rapid charge halfway along. They also keep really good statistics, which I've shown here. And particularly what this shows is that between 2017 and 2020, there was a rapid increase in the number of charge points installed for the use by public, particularly in the case of rapid chargers, which can charge a vehicle from 0 to 80% in between half an hour and an hour, depending on the vehicle. More on that a bit later. So that's where we are at the moment. Moving on to where do we need to be in the future, a study was conducted by the International Council on Clean Transportation that looked at EV demand, but also looked at different types of demand and different use cases for where people were charging vehicles, whether that was at home, in public, or at workplaces. And the findings that they came out with was that we would need 425,000 public electric vehicle charge points by 2030 if they represented 70% of new vehicle sales by then. And that's an if, because the policy's just been announced that by 2030 we should have all of the new vehicle sales being electric or zero emission. And so if anything, the results of this study are possibly an underestimate. But the most sort of striking statistic from this study is for us to get to that number by 2030, we need to increase the size of the UK's charge point network by 31% every year, year on year, for the years between 2019 and 2030. And that's quite a big ask. And the challenges that that poses are significant, not least for the energy sector. And we'll be talking about some of those later on. Just quickly looking at the coverage of the network as well, we've taken data from the National Chargepoint Register, which was an open data source looking at EV charging infrastructure, and plotted that out across the UK. And the reason we did this was that in March of last year, the UK government expressed an ambition that everybody should be within 30 miles of a rapid charge point at all times. And the first thing my colleagues and I did when we heard that was look at what the case is now. And it turns out we've already met that ambition. So it's actually less a case of coverage now and more a case of providing adequate capacity at the right locations. And I think that's the next step for public charging infrastructure in the UK, is very much targeting where it's going to be needed and making sure the capacity is there to really future-proof the network. The last slide that I'll show you on the sort of general overview, and this is certainly for those that aren't familiar with EV infrastructure or electric vehicles or the EV network in general, is just a very sort of high-level overview of the key stakeholders involved in the growth of the UK's EV infrastructure network. Now, this is a slightly confusing and complicated little graph, but effectively what we have on the left, the public sector, the Office for Zero Emission Vehicles, as it's now called, they renamed themselves towards the end of last year. The Department for Transport and the Department for Business Energy Industrial Strategy, or BEIS, they very much set the regulations in this industry. So the codes of practice, the standards by which the infrastructure network operators have to operate are set by those organisations, parts of government. We also have local authorities there as well, who very much are involved in the development of networks at a local level. Now that links into landowners. They are really important stakeholders in this, because ultimately electric vehicle charging infrastructure is only as useful as where it's located. If you put an EV charge point in the middle of nowhere, it's going to be useful to nobody. Whereas if you put a charge point at at motorway services, or at a busy shopping centre, or an area with very high footfall, all of a sudden even a small amount of infrastructure and slow, lower specification infrastructure can be quite useful and used frequently. So those landowners, whether it's car park owners, operators, businesses, or local authorities, or increasingly National Grid, who are arguably angling themselves to get into that space, landowners are very important, because we need to make sure the infrastructure is in the best locations. The energy network operators naturally are an increasingly important part of this, especially as we're now looking at really high-powered infrastructure that requires grid reinforcement in many cases. We've also started seeing, in the case of ESB, merging into charge point network operators. So the companies that actually operate the charge points, ESB has a wing of its business that runs charging infrastructure predominantly in Ireland, but there are also some charge points from ESB located in Coventry. We're also seeing that those charge point network operators, some of them also manufacture their own equipment. The equipment manufacturers are really important because we want the equipment to be more sophisticated, faster, more powerful, more economical to produce so that we can achieve that mass market uptake. And then last but not least, we have the software and back office providers, the platforms that help people to use the infrastructure, locate where the infrastructure is, and also manage the systems that govern how that infrastructure is operated. So it's quite a complex ecosystem, and especially in that some of the players merge across different categories. It can be a lot to get your head around, but it's very important to understand the breadth of the industry because it's important in the context of how the infrastructure network will grow in the future. Now, the next section I've got, taking a sort of going from the very high level overview of the UK down to probably the most granular level I possibly can. And we're just going to look quickly at electric vehicle charging equipment, what the different specifications are, what the use cases for those specifications are, and also roughly what the costs for each kind of charge point will be. This slide just very basically splits infrastructure into different categories. So we've got wall-mounted standard charge points, which we've put as 0 to 22 kilowatts. They operate over one phase up to 7 kilowatts, and then over 3 phases up to 22 kilowatts. And pretty much identical hardware to floor-mounted units, except they're mounted on the wall naturally. Wall-mounted charge points are going to be most useful at homes, domestic locations, but also some fleets. If you've got car parking bays that back onto walls, then it's naturally quite a sensible solution, and they can tend to cost quite a lot less. So if you can do it, that's usually the way that you go. For public charge points, floor-mounted is a slightly more common standard because it doesn't rely on there being a wall behind the a parking bay, which in the majority of cases there isn't going to be. But like I said, the hardware is pretty much identical to a wall-mounted standard charge point, 0 to 22 kilowatts, either over a single phase or 3 phases. And then moving up to rapid charge points, these are over 3 phases. AC, they can provide up to 43 kilowatts, and DC, they provide 50 kilowatts. These are the sort of charge points you find at motorway service stations and petrol forecourts. Those kind of situations where you want dwell time to be as low as possible. And the bottom left, we've got wireless charging, which is very much an emerging concept and not one that's really at market yet. It's only really available to electric vehicles that have been retrofitted to accept a charge, but it gives you an idea of the capability of a wireless charger. It's talking sort of 3.5 to 7 kilowatts over alternating current. That is being developed, and we're increasingly seeing companies looking at producing faster and even rapid standards for wireless charging. We'll talk a bit more about wireless charging later on, though. And then last but not least, and probably the standard that it gets the most attention, is ultra rapid chargers. Now, these are the sort of chargers that can provide an 80% charge even for a large battery in an hour to an hour and a half kind of time. So they are very fast, but also have a massive draw on the grid, over 3 phases, DC. 150 kilowatts plus. Some of these are now specified up to 350 kilowatts. Even if the vehicles aren't ready to take that much power, they are on the market now. So that is an area of the industry that's moved on very quickly, and those sort of charge points are going in the ground across the UK now. So it's not they're not an emerging concept. They are definitely at market. Now, with the different power of charge points, the other element of this is charge point connector standards. So there are 3 different types commonly now. There used to be more, but thankfully it's been rationalized into a less amount. The first type, and by far the most ubiquitous, is the type 2 connector. This is alternating current either over a single or 3 phases. On a single phase, it's up to 7 kilowatts. And then over 3 phases, if you have a rapid charger, it can be up to 43 kilowatts. Not many vehicles are equipped to take that. In fact, I think there's only one vehicle on the market now, the Renault Zoe, that can take 43 kilowatt charge over a Type 2. So that's quite a rare thing to see now. Some notes on that: there is a modified Type 2 connector that's used by Tesla vehicles to provide 120 kilowatt charging over a DC. And also Type 2 connectors, the most important thing to know about them is they're compatible with virtually every electric vehicle. So even if they're the slowest of the standards, if you want to put it that way, there's a very important place for them, because otherwise we'll have an ecosystem where we basically need to provide 2 or 3 different standards to make sure that we're providing for all vehicles. Because of Type 2, we know that if it's a slow or a fast sort of 7 kilowatts, 22 kilowatt charge, that's the only standard we need to worry about, because all vehicles can accept it. So that's why Type 2 is quite important. The other 2 standards are both DC, typically found, well, almost universally found on rapid chargers. The first is CHAdeMO, which is currently up to around 150 kilowatt charging, although that's being developed. The standard is compatible with vehicle to grid, which is something we'll talk more about later. It's the only standard at the moment that's widely compatible with vehicle to grid. And CHAdeMO is also the dominant standard in the East Asian and American markets. So it's important, but not necessarily in the UK and not necessarily in Europe, as we go on to CCS, which is also a 3-phase DC standard. These are now equipped to provide charges of up to 350 kilowatts. It's quickly becoming the dominant standard in Europe, mostly because of European legislation, which has been transposed into UK law in the Alternative Fuels Infrastructure Directive back in 2017, I believe. The nifty thing about this socket is the top half of the socket doubles as a Type 2 connector. So for a vehicle manufacturer's perspective, it makes the design of the system just one bit easier. And the only major limitation of that right now is that it doesn't currently support V2G, but the standard is being developed, and I believe demonstrator projects are on the horizon to look at V2G over CCS. Indicative costs for equipment, just to give you an idea as to how much these charge points cost. For wall-mounted charge points, they can be quite cheap. So anything up to 7 kilowatts, which is the sort of thing you'd install at home and potentially at a workplace. They vary from around £300 to £1,500, depending on the standard of equipment that you buy. Things over 7 kilowatts that work over 3-phase, they can be roughly £1,800 to £4,000, and if they've got 2 sockets as well, that adds an extra cost. Floor-mounted units, the additional cost is mostly just in the extra hardware and the extra strength that needs to be built into the unit to protect it from being walked into and potentially crashed into by cars. So there's a little bit of a premium paid there to have wall-mounted units. Rapid chargers, by virtue of the extra equipment and transforming equipment inside the unit, is then significantly more expensive. £15,000 to £30,000, depending on the specification, is a ballpark there. And as yet, I don't think we have any accurate costs for wireless charging or ultra rapid charging, so I won't speculate on those, but you can reliably assume that they're both going to be more expensive. Those are the equipment costs. The next thing, DNO costs. So when you install this type of charging infrastructure, you typically need certain works on the distribution network to support it. For a small installation, so what we have there is indicatively 1 to 3 fast chargers at around 22 kilowatts, or a rapid charger at around 50 kilowatts. The typical cost to install that is going to be around £1,000 to £3,000, depending on a few things, including how close the charge point is to the distribution network, but also what the strength of the local network is, because if it's already constrained, then the chances are even a small installation might well trigger some fairly costly upgrades. Moving up to a medium installation, when we're talking about banks of chargers, this is where distribution network operator costs can be quite significant. When we're trying to prepare the grid to take, in some cases, 500 kVA plus, in that example, up to a megavolt amp of load. At that point, you're almost on the verge of it needing its own distribution substation. In most cases, it can be quite expensive. But then above that, when we're talking about massive hubs of rapid chargers, 20 plus rapid chargers, or several ultra rapid chargers, which will be in the megavolt amp scale, that's when the costs ramp up significantly, because you're inevitably talking about installing a distribution substation and potentially even a primary substation to support the installation. Those costs can be quite scary, and we'll talk about this a bit later on. But that's one of the reasons why the rollout of EV charging hubs has been slower than I think a lot of people would have liked. More costs. You're getting the impression that that charging infrastructure, it's not quite a 3-pin plug on a stick anymore. It's pretty serious business now. So when installing charging infrastructure, there's also the installation cost to consider. So the excavation of the ground to install the cabling, earthing can sometimes add an additional cost depending on where the charge point's installed. The cabling is an additional cost. The signage is an additional cost. The electrical cabinet is an additional cost. Road markings, protective barriers. You get the idea. This adds up to quite a significant amount. And once you've got it all in, you're talking around £500 for a wall box, around £2,500 to £5,000 for a freestanding column charger, and then for a rapid charger, it's going to be over £20,000 without really breaking the sweat. So again, significant costs. It gives you an idea again why the rollout hasn't happened at a lightning pace that some people maybe feel that it should have done. So now that we've gone through the sort of the basics of different types of infrastructure, the next section I've got is looking at innovative technologies. So these are the new technologies that have various different use cases that are being employed in various problems that they're intended to solve. Some of them are fairly at market, and some of them are very much emerging. The first of which is very much at market. Smart charging is basically equipment that in essence can intelligently decide whether to turn a charge point on or off, and then also in some cases to scale the power of the charge in response to an external command. So this can have quite a few different benefits, the most prominent of which being that it allows a charge point to take advantage of time of use tariffs. So those of you who are familiar with Octopus Energy and their time of use tariff, you might have spotted that at some points over lockdown, when there's been very low energy use and very high renewable generation, they have actually been paying their customers to use electricity. And by using a smart charge point, you can ensure that the vehicle is being charged at the time that it's going to be most economical, but also has the greatest benefit to the grid and to the environment because you're maximizing the use of renewable energies. This type of equipment is already commercially available. I believe the law now states that all home chargers need to be smart capable, or it will certainly be coming into law quite soon under the Automated and Electric Vehicles Act that home chargers should be smart capable. They're typically a bit more expensive than what we call a dumb charge point, which I always think is quite a funny expression. But the smart capability will have both long-term benefits to the grid, but also to the customer as well. They're able to access time of use tariffs and make the battery in their vehicle, potentially make them money, and that's quite an important thing. The only limitation is that it needs connectivity to be functional. So there is a little bit of a question about whether this will work in rural communities, like really rural communities around the UK. But I think most places it's not an issue. Moving up one step from smart charging is vehicle to grid, which I mentioned earlier on, V2G. This is, as we put there, everything that smart charging can do, but better. So what we're talking about here, all of the capabilities of a smart charger to be able to turn a charge on or off or scale the charge in relation to an external command, that's still there. But now we've got the additional benefit of the charger can actually return energy back to the grid, or back to a house or back to a business. And this provides a number of additional benefits, some of which the value and the importance of them might be overstated, but some of them certainly do have a very important value. So in this case, from an energy management perspective at a building level, whether you're a consumer or an energy manager within a business or an organization, this allows you to store energy when it's cheapest and use it when it's most expensive. and that provides a cost-saving incentive. It also allows you to store energy when renewable generation is greatest and release it when it's lowest, and that provides an environmental incentive. So there's various reasons why V2G adds value to an electric vehicle. It effectively makes it a battery. Well, at least while it's static, it becomes a battery, and a battery that can be used in a way that any other battery could typically be used. In terms of the readiness of this technology, the Nissan Leaf, which has been on the market, an electric vehicle that's been on the market for many years now, has been compatible with V2G more or less since its first generation, I believe. And most of the demonstrator projects that have gone on have focused mostly on the Nissan Leaf. The units are available to buy mostly through demonstrator projects or attached to demonstrator projects, but they're currently quite expensive. And I think if memory serves, the last time I got a quote for a V2G charging Chargepoint, even a home one, we were talking in the region of £4,000 to £8,000, which is significantly more than a regular standard smart charger. At the moment, the reason why they're limited mostly to demonstrator projects is because otherwise the economies don't add up. But in the future, they're expected to achieve a scale which allows them to be cheaper. And a number of organisations look at V2G as being a bit of a saviour to the grid in the UK. We'll talk a bit more about that later on. V2G R&D projects that are going on at the moment, this is just a selection, but it's more to illustrate that there is a lot of work going on around V2G, and that highlights the importance strategically of the technology to the UK, to the national grid, to distribution network operators and the energy sector as a whole. It has much promise, I'll put it that way. The technology offers an awful lot of potential. At the moment, the issues are mostly around scaling it up and making it affordable. But I think that's something we all expect to happen. And once it does, the only remaining barriers are just making sure the vehicles are compatible. And again, that's something we're anticipating will also happen over the years. Wireless charging. This is one of those unicorn technologies that I think everybody has a dream that they could basically just charge the vehicle without having to plug it in, potentially while the vehicle's moving along. The technology to do that is readily available. Many of you might well have a mobile phone that can charge wirelessly using a QI charging pad or something like that. And the technology to do so with a Chargepoint is fundamentally identical, just scaled up to the nth degree. We divide wireless charging into two different categories. Firstly is static wireless charging, which, as its name suggests, the pads don't move, the vehicle doesn't move, it parks on top of the pad and then the charging session activates. The pads are typically laid above the road surface and are most likely to be useful in situations where vehicles are parked and not moving. They cost around £50,000 at the moment, which again is a big step up from the cost of a regular plug-in charge point, which is somewhat limiting the speed at which this technology can be rolled out. And the real limitation of it is that the vehicles need to be parked very, very precisely, at least in the current iterations of technologies. There's a matter of inches between a charge beginning and not beginning, and that's a bit of an issue and something that companies are working to overcome. The other type of wireless charging, and one that has a lot of promise and is attracting a bit of interest from a research and development perspective, dynamic wireless charging. So in this case, the wireless charging coils are fitted beneath the road surface, and the principle being an electric vehicle that's retrofitted with the technology to accept the charge will be able to charge as it moves along, which is what a wonderful world it would be if all of our motorway lanes had that technology equipped. But alas, at the moment, in the current iterations of the technology, we're talking about roughly £500,000 per lane per kilometre. I haven't done the maths to calculate what it would cost for us to therefore retrofit every motorway lane in the UK, but I don't think I need to do the maths to know that it's going to be an extortionate number. So the technology needs to develop significantly for us to really roll this out at scale. I think in the short term, where this technology fits best is very targeted deployments focused on predominantly heavier vehicles, which have the greatest limitations for range and that sort of thing. But yeah, the cost of dynamic wireless charging is significant. And the main reason for that is that you need to dig up the roads. And that's something that Static wireless charging, generally you don't have that barrier as you mount the pad onto the road surface, and the civil engineering works are nowhere near as extensive. I believe oh no, it's not the last technology I'll talk about. The penultimate technology I'll talk about, semi-autonomous charging. So the joy of wireless charging is that you can park your vehicle over the pad and the charging session will begin of its own accord. So between wireless charging and conventional sort of plug and cable charging, there is this concept of semi-autonomous charging. The picture on the left there is a pantograph charger manufactured by ABB that's capable of providing a 350 kilowatt flash charge, they call it, to heavy vehicles, and it's already been deployed. It's being used for buses, and it's also something that they're now looking to roll out more broadly. Very much targeted at bus routes that are going to be compatible with the technology. So longer bus routes, it's not going to be a solution to that problem, but certainly shorter bus routes, circular routes, that sort of thing. This technology is a very promising way to electrify buses and heavy vehicles. And then the picture at the bottom, which I had a joke with my colleagues, is what Wall-E did after he starred in the Pixar movie. There are experiments going on with the concept of charging robots. I have to admit, I'm a little skeptical as to not just whether this will work, but whether it's really needed. But the concept is quite good, and there will inevitably be some use cases where this kind of semi-autonomous charging equipment will be useful. For example, those with impaired mobility and disabilities. This makes a lot of sense in those cases, and potentially could unlock electric vehicles for a greater demographic. So it's not one to be taken lightly, but I think that will probably remain a niche part of the sector. That's at least my professional opinion on this. And then the last slide I've got here is just looking at novel form factors. So innovation isn't always about the fundamental technologies behind charge points. It's actually around the form of charge points and modifying that form so that it suits different environments better. So I've picked out 4 different types here that kind of give you a bit of an overview as to how companies are experimenting with form factors of charge points. The top left, the pop-up chargers, as the name suggests, they sit flush to the ground, and then when they're used, either rotate up out the ground in the case of the unit on the left, or are electromechanically propelled out of the ground in case of the unit on the right. And that means that while they're not being used, they present no road clutter, there's no additional street furniture, which has potential benefits, especially in paths that are quite narrow. In the top right, we've got charging equipment that uses existing supplies. So these are very small form factor charging equipment that fits onto something with an existing supply. The most common of these, and you'll see them in a lot of places across the UK now, are lamppost chargers, which draw on effectively capacity that was made available when lampposts were upgraded to LEDs. They don't charge particularly quickly. I think, unless memory is failing me, they'll provide anything from between about 2.5 to 6 kilowatts. So they're not going to charge a vehicle up quickly, but the benefit is that they can be installed in basically half an hour, and they cost next to nothing compared to other units. I think the installation equipment costs for this basically work out to around £1,000 to £2,000 a unit, which is significantly cheaper than installing a fully fledged freestanding charge point. So there's a big role for those. Modular charge points, this is something I don't believe has been rolled out on scale as yet, but the concept is quite similar to a pop-up charge point, except rather than the charging equipment coming up out of the ground, you effectively have a connecting equipment that penetrates into a socket that's mounted beneath the pavement surface. So the principle is the same in that while it's not being used, it's completely flat to the ground, but there's just a different approach to how it works in practice. And then the low-lying chargers, I believe it's only the one company that's currently looking at this kind of technology now, but these are fixed chargers just like any other, except the majority of the electronics and power electronics are stored beneath the pavement surface, so they create as little clutter as possible. There's certainly a bit of conversation about whether these are actually safe. I think there's some good reason for that conversation, but the principle of them is still quite sound in that it prevents sort of infrastructure popping up and ruining the aesthetic of the local environment, or being just generally too in people's faces. So it's potentially has a role to play. but the different shapes and sizes of charging infrastructure to meet the conditions of different environments is, it's quite an interesting thing to consider. Now, on the topic of different use cases and charging in different environments, the next section, this is where I want to talk a little bit about electric vehicle infrastructure challenges from a societal perspective. And this is something that's quite important to me because I feel like a lot of these questions aren't asked enough, and the more that I can at least prompt people with them, the better it'll be. So to illustrate what I'm about to talk about, I've taken the example of low-hanging fruit and a fruit tree. In this context, the low-hanging fruit, rapid charging, destination charging, home charging, the market for all of these things is very well developed. If a landowner wants any of these installing, or if a homeowner wants any of these installing, they can call a number and it will happen in a week or a month's time. So there's no issues with any of this. The business case for all of it is quite well established. The mid canopy, these are the challenges that I feel the industry and the government are currently addressing. So on the top left, rapid charging hubs, this has been held back for quite a while because the grid requirements of potentially megavolt amp scale infrastructure, it costs so much that it's been held back. Funding is being introduced to overcome that, which we'll talk about later. Workplace and fleet charging can also be quite challenging because the grids at a professional premises, an office, can already be fairly constrained, and adding an additional load during working hours can introduce new demand, which can be problematic. Rural communities, as you can imagine, where there are less people, the business case for EV infrastructure is less strong, and therefore trying to find ways for EV infrastructure to be made to work for rural communities is quite important. And then public residential charging, very well spoken. A lot of people speak about this as a challenge, but if you don't have a driveway or a garage, how do you charge an electric vehicle? And what are the solutions that can really facilitate that in the future? There is government funding available for local authorities to install charging infrastructure in residential areas, so it's something that's being worked on, but it's still a significant challenge and one that can make or break an EV as a concept for a lot of users. The upper canopy, these are the ones that I don't feel like anyone is talking about, but are nevertheless really important issues. The rights of tenants and leaseholders. So if you don't own your property, whether you're a tenant or whether you're a leaseholder, at the moment you need the permission of your landlord or your freeholder, or potentially both, to install an EV charge point. And if they refuse, you've basically got no recourse. And there's a lot of people that fall into this category. I believe I have numbers for this. Although I can't seem to find them at this point in time, which is great fun. Here we go. So tenants and leaseholders, we've got 4.5 million privately rented households in the UK and 4.3 million households that are in properties owned under a lease. So we need to do something about this group of people. We can't just ignore it and pretend like it's not a problem. It's a massive proportion of the population. So the sooner we start getting our heads around that, the better. Disabled accessibility, there's 1 or 2 projects popping up now looking at how to make EV charging more accessible. Again, this is a really big proportion of the population. There are 11 million individuals in the UK that have long-term illnesses, impairments, or disabilities, and there are 2.3 million blue badge holders in the UK. So if we don't make sure the infrastructure is accessible to them, we've ruled out EVs for a big group of people. And again, this is a topic that I don't feel is being engaged with particularly significantly right now. EV charging equity. Now, this is a concept that is very far in the future, I suppose. But how do we make sure that people that rely on public infrastructure are not disadvantaged by that reliance? And to illustrate this, I'll go on to my next slide. So if you take 2 EV owners who are demographically identical, have the same vehicle and drive it the same amount of miles, one that can charge at home that's paying around 10 pence per kilowatt hour to recharge their vehicle overnight, costs them around £420 a year to recharge the vehicle. In the same case, the other person that doesn't have the means to charge at home, paying 18 pence a kilowatt hour on a public charge point, which frankly is a very, very low rate for a public charge point, it will cost them around £756 a year. So over an 8-year period, that means the person with access to off-street parking, a driveway or a garage, has saved nearly £2,700 over the individual that didn't. And that, at least in my view, isn't something that we can allow to happen. I think that's a ticking time bomb, and things we do today are very much impacting whether or not that will become an issue in the future. And it's something I try to engage with companies more as we develop the industry. So the last section I've got, just looking at electric vehicles and the grid, which hopefully will be of interest to many joining this group. What challenges do electric vehicles present for energy suppliers, the energy network operators and energy managers? Firstly, I'll start with national electricity demand challenges. So according to National Grid's 2020 future energy scenarios, electric vehicles could add up to around 22 gigawatts to peak UK electricity demand. This is roughly supported by one of the first projects looking at the constraints that this will put on the distribution network, the My Electric Avenue project that was run by Scottish Southern Energy Networks. It was a real world study between 2012 and 2015, and it found that when 40 to 70% of households have an EV, 32% of the medium and low voltage feeders would need upgrading or replacing, which accounts for 312,000 circuits across the UK. So that's a big number, and it's thought that that will cost around £2.2 billion by 2050. Massive issues. The counter to this is that those studies are all assuming that there's no smart charging or no technology that's used to abate the demand from EVs. So National Grid in 2020 future energy scenarios showed that smart charging could help to reduce peaks by shifting demand. So that the hashed line in the center of those scenarios shows the impact of smart charging over having dumb charging in inverted commas in the dotted line at the top. And then by using vehicle to grid, you can effectively return energy to the grid. And so the impact on the grid is to remove demand and actually supply demand in different parts of the grid. So there's a technological solution that enables electric vehicles to actually be a solution to grid constraints and not a problem. Additionally, we've got Western Power, the Electric Nation project that they ran, shows that 48% of plug-in events take place between 5 p.m. and midnight, and on average the vehicles are plugged in for 12 hours but are only charging for 2 hours, and that indicates that you've got an awful lot of room for flexibility. So if everybody's getting home and plugging in at the same time, and we at 5 to 7 o'clock in the evening where we already have constraints, why not instead use technology to displace that demand to the middle of the night, or a time of day that's where there's already no significant demand, and it won't cause that kind of problem. So from this, you might be getting the impression that smart charging is somewhat the savior, and for long stay charging events, smart charging does allow us to basically reduce some of the constraint that's placed on the grid. This applies most strongly to domestic charging at home and workplace charging, where vehicles are potentially plugged in for several hours or even overnight. And then once you add V2G, you add the options of being able to store renewable electricity and store cheap electricity, and then use it when there's either no renewables or when electricity is at peak rates. And also adds a benefit to energy managers because you reduce the additional peak caused by EV charging, and that means you don't need to increase the capacity of a building, or at least the increase will be minimized. And it also allows you to maximize the utilization of any on-site renewable generation, which has the benefit of greenhouse gas reductions improvements. So 80% of charging currently happens at home. We're talking about solving that challenge with smart charging in V2G, but it doesn't solve the challenge for public charging, especially for rapid and ultra rapid charge points. And so I believe my last few slides, just looking at public charging, to make rapid charging work and not place immense demands on the grid, we're currently seeing developers increasingly coupling EV charging with solar generation and with battery storage. And that way they're minimizing the impact on the grid because the battery storage acts as a buffer, and the generation allows them to completely detach from the grid in the right conditions. But it also provides them with additional revenue streams through frequency response and demand services, grid services, which solidifies the business case for the overall development. And then my last slide is just looking at the role of the national grid. So at the moment, the UK government's planning to make what's thought to be around £500 million of funding available to cover the costs of grid upgrade to support EV charging infrastructure projects, rapid charging and ultra rapid charging, predominantly on the strategic road network. Alongside this, we've also got National Grid exploring how they can install large-scale, high-power EV charging hubs connected directly to the transmission network. And the reason this is of interest is because 60% of motorway service areas in the UK are within 5 kilometres of the transmission network, and 20% of them are within 1 kilometre of the transmission network. So it's a fortunate cross-section of areas where demand is likely to be high, an area where potentially supply can also be quite easily made to match. And so this is why National Grid are increasingly getting involved in the EV space. There's a natural link between the transmission network and high power EV charging infrastructure on the strategic road network. So yeah, that was the crash course in electric vehicles. I hope I've covered as much as I could to give you an introduction to EVs and the context of them within the energy networks in the UK. That took longer than I thought. I think I get carried away talking about this topic, but hopefully we've still got some time for questions, which I'm more than happy to take. Let me see if I can get the question panel to open. Here we go. I'll scroll down to the ones that I feel like I can answer most easily. It's good. I'll put this on the other screen so that I'm not looking to the side. So do you envisage V2G enabling peer-to-peer trading in the future? That's a very good question, and something I think in the UK has barely had any attention at all, but across the EU, there's been a few different experiments, mostly using blockchain technology as a way of enabling V2G peer-to-peer trading. I have to admit, it's not an area that I've got a lot of experience with, but there are definitely companies looking at how to make that happen using blockchain in the EU. So that's something that is going on, albeit just not in the UK. Just scrolling through. I think a few of these I've answered as I've gone through the different slides, so I'm just getting to the ones that I've sorry, it's just going through the questions. Okay, here we go. How do you think the decarbonisation of HGVs will be achieved? And this is a really good question, and not something that I covered in that presentation, and probably for good reason. With HGVs, the challenge they happen to be some of the highest mileage vehicles, and also some of they're already heavy, basically. So installing batteries of a capacity that would actually give them the range to operate effectively will throw the vehicles into a weight category that would make them really useless as goods vehicles, because higher battery weight means that the payload of the vehicle would be less. So they're not a vehicle category that's easily addressed using EVs or with battery electric vehicles. This is where I think hydrogen has its best and most relevant role. There is a question there on hydrogen. I'll admit I'm not a specialist in that subject, so I didn't want to go into too much detail, but the benefit of hydrogen in the context of HGVs being that the energy density of a hydrogen fuel tank is considerably higher than a battery, at least at the current stage of development. But also the refueling times naturally are significantly lower, and so the operating duty cycles of a HGV naturally fit slightly more nicely and neatly with hydrogen than they do with battery electric vehicles. So in my personal view, I think decarbonisation of HGVs is probably one that will occur as hydrogen technology, and particularly hydrogen refueling infrastructure, expands across the UK. There's a question here, just checking time. Yeah, I've got time for this. Will the government subsidise costs if one wants to install a charger at home? Yes, they will. It's not. They have a grant scheme called the Home Charge Grant, which I believe provides up to £350 towards the cost of a domestic charge point. Those grant schemes are updated on a fairly regular basis, and it's envisaged that at some point they will probably stop offering it. The interesting thing about that grant scheme is in its early days, they allowed anyone to claim it, whether they had an EV or not. So you had a lot of people that didn't own EVs just getting a charge point installed because it was basically offered on a plate to them. Now, unfortunately, you need to own an EV and provide your registration number for you to be applicable to that grant. But there is support available. From Richard, why do you think the government wants to mandate smart chargers for home? Is it simply to allow the DNO to monitor load, or might there be a tax-related motive? That's a very sly question. I would be surprised if there wasn't some degree of tax-related motive in there. Certainly throughout the consultation event, it wasn't something that came up. But it won't have escaped the government. It certainly won't have escaped the Treasury that there's an impending black hole of tax receipts from the transition from petrol and diesel to electric vehicles, and they are going to need some way. They'll need some way to identify how much we're driving our vehicles. I think the only reason why that might not turn out to be the case at the moment, the common view is that will replace vehicle excise duty with a cost per mile tax system, and that kind of system could effectively be administered via MOTs or potentially just via technology on the vehicles. So whether or not smart charging is essential to that, I'm not so sure. An interesting point I would make on smart charging, though, in that kind of regard. At the moment, an issue that prevents somebody with a driveway and garage, the reason they can access considerably cheaper electricity for their EV than somebody that doesn't have a driveway or garage is firstly because VAT is charged at 5% rather than 20% for a domestic supply versus a public supply. And secondly, they already have a domestic tariff which opens up time of use and various other incentives that make it considerably cheaper for them to charge at home. If one of the ways that we could potentially address that balance is some sort of fee-based balancing mechanism which uses smart charging at homes to increase the cost for those that can charge at home and decrease the cost for those that can't, I don't suppose that's going to be very popular with an awful lot of people. But it is a technological route that they could introduce something like that. So yeah, there is potential for smart charging to be used in different ways. I'll go through one more question. I think I've just about got enough time. A question that says, where are the private investors who will accept a lower return on investment compared with other investments? This is a good question. With charging infrastructure, the business case for it is quite an interesting thing. Rapid charging, as I've mentioned in this presentation, costs significantly more, almost 10 times more than a standard charger would. And we're talking about £40,000 per charge point. If we're talking about installing them in hubs, we're talking about millions of pounds. But the reason why that's an attractive investment to an investor is because a rapid charger can fully recharge sometimes a dozen or more vehicles a day. And if each of those are paying the same amount as they would on a different charge point, it means your sales capacity is effectively increased. Whereas a 7 kilowatt charger, especially one that's in a residential location, is probably going to get used once or twice a day. So even if the cost of the charger is significantly lower, the business case is much weaker because the income and the turnover just cannot meet the operating costs, and the return on investment is really low. It's quite a challenging area of the market to attract investment. So I hope that sort of answers that question a little bit. It's mostly that the investment is being directed towards those high power rapid charging infrastructure projects where there's more potential for revenue generation. I think that probably brings us about to time.